So I'm kind of gonna give you kind of like an overlay of what's gonna be happening. So what's gonna happen today? Actually, gonna be a pretty quick lecture where you're gonna finish up chapter 15, and then that's it. So if you kind of remember, there's only like one question left for chapter 15. So we're gonna finish up chapter 15, and that'll be it for today. And what's gonna happen on Tuesday, we're gonna go over chapter 16. And then on Thursday we're gonna pretty much it's gonna be like a review day where you can ask question about the review problem that we gave you on Blackboard. And then that weekend you're gonna take test number 3. So just to kind of repeat myself on today where you're gonna finish a one problem chapter 15, and then that's it for today. We're also on Tuesday we're gonna go over chapter 16, which is the last chapter for test number 3. On Thursday, we're gonna do a review where you're gonna ask question about the review question I put on Blackboard. And then I'm gonna open up the test number 3, and you'll have the entire weekend, and I'll give you all the way to Tuesday to complete test number 3. All right. Any question in regard to that? All right, there's no question. Let's just get started. So if you have your chapter 15, yes, go to the last page because that's pretty much all we have to do for today. So we'll go 132, we'll go math 115. Hopefully turn on. Okay, so hopefully everybody could see that right now. All right, so let's go ahead and do this. So for this example, it's an example of a sampling distribution for the mean. So it said the length of a human pregnancy is right skew distributed with an average pregnancy length of 266 days and a standard deviation of 16 days. So they gave me 3 important things. So the first important thing that they give me is the distribution. So they tell us it has a right skew distribution. All right, so they tell me we have a right skew distribution. They also told me the mean length of a pregnancy. So the mean length of a pregnancy will be 266 days. And they also told me the standard deviation. So the standard deviation of a pregnancy is equal to 16 days. All right. So far, that's what's given to me in the problem. Everybody gets so far that this is a right skew distribution. The mean is equal to 66 and sigma is equal to 16. All right. So up next, we're gonna go ahead and do is we're gonna do part A. All right. So if you look at part A is asking for this problem, do we need to apply the central limit theorem? So if you look at it, since they tell us the distribution is the right skew distribution, for this one, we do need the central limit theorem. Because if it would have been a normal distribution, then we don't need the central limit theorem. But since this is a distribution that's not normal, we're going to need the central limit theorem to be able to say that it is either approximately normal. So we're going to say, yes, we do need So for this one, I'll say, yes, we do need to apply the central limiter since the distribution is right skew. And that's it for A. Any question in regard to A? All right, so let's go ahead and let's do B. So for B, it says, what is the probability a randomly selected pregnancy lasts more than 260 days? So for this one, what do they tell us? How many people or how many female are they randomly selecting? If you want, you can put it in the chat or just shout out the answer.
1.
Yeah, 1. Cool. Thank you, Brenda. Yeah, so the key thing here is that a randomly selected pregnancy. So that usually means just one person was randomly selected. If they would have said like, what are the probability that 5 randomly selected pregnancy or 20 randomly selected pregnancy? But for this one, so it said a randomly selected pregnancy. They're telling us that n is equal to 1. All right, so if n is equal to 1, is our sample size big enough? Like for this one, can I use the CLT to say that this is approximately normal? No, because if you look at it for the central limit theorem, so I'll put CLT, n has to be greater than or equal to 30 to say is approximately normal. But the thing is, if you look at it, if n is equal to 1, in this case, 1 is smaller than 30. So in this case, for part B, we're not able to do part B because we don't know is a normal, well, approximately normal. So for part B, we can't do that problem. So we could just skip part B. Any question why we could just skip part B? Okay, so let's do part C. So for part C, it says, suppose a random sample of 50 pregnancy is obtained. Describe the sampling distribution of the sample mean length of human pregnancy. So for part C, how many pregnancy are we randomly selecting now?
50.
Yeah, 50. So n is equal to 50. So that means we're going to find mu of x bar. We're going to find sigma of x bar. And we're also going to say, well, we already know it's not normal. So we're going to say if this distribution is not normal, or if this distribution is approximately normal. All right, so if you look at for mu of x bar is equal to mu, so that's equal to 266. If you look at sigma of x bar is equal to sigma divided by square root of n, where n is 50. So we're going to say 16 divided by square root of 50. And if you look at it, we get roughly 2.26. Everybody good on how we got 2.26? All right, so up next we're gonna decide if the data set is non-normal or if it's approximately normal. So if you look at the n is 50. So what we want to do, we want to see if we can apply the central limit theorem, which says if n is greater than or equal to 30, we could say it's approximately normal. If you look at this one, since 50 is in fact greater than or equal to 30, this passed. So that means we have a data set that now we could say is approximately normal because the sample size is big enough. All right. Any question in regard to C? All right, so let's do D, and then that's it. So for D, it says, what is the probability that a random sample of 50 pregnancy has a mean pregnancy period that lasts more than 260 days? So we're gonna go ahead and draw this out. So we put mean of 266 in the bottom. We want to find the probability that the pregnancy lasts more than 260 days. So 260 days is somewhere over here to the left of 266. So let's say 260 right here. And if you look at the keyword here is more. More, it's telling me it has to be bigger or more than 260 days. So if it's like 261, 270, 280. So we say the right side. So now what we want to do, we want to figure out what mu is, what sigma is, what the lower bound is, what's the upper bound. All right. Any questions so far for that drawing? All right, so let's go ahead and do the mu. So mu, we already found it to be 266 days. So you put 266 days. If you look at sigma, sigma, we already found it to be 2.26. For the lower bound, for this case, what would be my lower bound? And remember, you can just type it into the chat.
260.
Yeah, 260. And for this one, what would be my upper bound?
Infinity.
Yeah, infinity. Perfect. If you have a TI-83 or 84, just do 10 to the 10 power. Everybody good for the lower bound, upper bound, mu, and sigma? All right, so let's go ahead and do this. So I'm first gonna deal with the TI-83, and then I'll do it with class calc, and then that's it for today. So you want to turn it on. So you go to second, you go to vars, and you go to normal CDF. So on normal CDF, you do lower bound, so you do 260. Now you do the upper bound, where the upper bound is 10 to the 10 power. You do mu, where mu is 266. And you do sigma, which is 2.26. Then you go over here where it says paste. You go to enter. And if you look at it, we get 0.996.
Can you also do it on class calc? I kind of forgot how to do it again.
Yeah, because we're gonna do it first with the TI-83, and then I'll do it with the class calc.
Okay.
But that's it on how to do it with the TI-83. So for the people who have the TI-83, any question on this?
No.
All right, cool, thanks. All right, so I think I'm gonna do it in class calc. So on class calc, did I close my class calc? There we go. All right. Everybody right now can see class calc?
Yes.
All right. So for class calc, what you want to do, you want to first have your keyboard. Well, first make sure it's in graphy mode. If it's not in graphy mode, you're not gonna be able to do any of this. So once it's in graphy mode, make sure you have the keyboard up and going. So you want to hit the stats button. You want to go to distribution, and you want to do a normal distribution. So for the normal distribution, you put mu, which is 266. You want to put sigma, which is 2.26. If you want to see a picture of it, you could just press the magnifying glass. And here is our distribution. So since we want to find the probability of this distribution, we're going to do a CDF. So we'll say CDF, and you just want to put the lower bound. So the lower bound is 260. The upper bound is infinity. So if you look at it, you get the exact same answer of 0.996 as when I did it with the TI-83. All right, but that's how you do it with ClassCalc. Any question for ClassCalc?
No.
All right.
Also, my internet cut off at the start of the class. So what did you say about it again? I know this lecture is short, but yeah, forgot what you said because my internet cut off.
Pretty much I just said pretty much the layout of what we're gonna be doing for the next, well, for next week. So for next week on Tuesday, we'll finish up chapter 16. On Thursday, I'll take question about any other review question on the practice exam for test 3, and then for the weekend, you're gonna have to do test number 3.
Okay.
Oh, next weekend is test 3?
Yes.
Sounds good.
Yeah, so that way it's not like rush.
Okay. I'm good. Thanks.
All right. Well, that's pretty much it for today's lecture. Any question in regard to today's lecture?
Yeah, what did you say? I just logged on like a minute ago.
Oh,
No, I just probably watched the video then.
yeah, pretty much all I said. Today we just went over the last problem on chapter 15 notes. On
Okay.
Tuesday, we're gonna get started with chapter 16 notes. They're not that long. And then on, what do you call that? On Thursday, I'll just take any questions, because if you have been on Blackboard, I already put a practice exam. So if you just want to start practicing on that exam, and then on Thursday, I'll just take any question you have about that practice exam.
All right, for sure. Sounds good.
All right. Any other questions?
No.
All right. So I'll close up the meeting. I'll open up the meeting in case you have any question in regard to anything. So I'll just start holding my office hour like in a minute or so. So if nobody have any question, I'll see you next Tuesday. Have a good weekend and just stay safe.
Thank you.
All right, good morning, y'all.
Good morning.